This is Brian Putt. Today I'd like to talk to you about tornado charts. This shows three different tornado charts. What do these tornado charts have in common? Well, they all come from the same model. They're multiplying two random variables together. But how do they differ visually? Do you see the difference? I think so. What do each of these tornadoes tell us? I think they're telling us a different story. So let's start with the mathematical one. The mathematical one is good when you're just getting started with a model. Basically good for testing to see if the variables are basically going in the right direction and order of magnitude might be right. In other words, does the capital cost of a project have a relative same impact as operating costs? The second chart, the percentile, says, let's look at the P90 and the P10 outcomes of each of those input variables and see how it impacts the value measure if we just change that one variable, keeping all of the variables at the mid value. And then the third one, the probabilistic, is asking if I use the same P10, P90 endpoints as I did in the percentile tornado chart, but if I let all the other variables continue to be uncertain, how does it change my expected value? You'll notice that in the mathematical, that center line is 100. And the center line of the percentile is 100. But the center line of the probabilistic is different. It appears to be close to 125. So all these charts are different. Some show symmetry up and down, others don't. Others make the variables look the same. And the percentile and the probabilistic do not. Let me show you a speech from Elon Musk at the Caltech commencement exercises in 2018.
And it's amazing how, even though you can show that something works on paper, and the calculations are very clear, until you actually have the physical object and they can drive it, it doesn't really sink in for people. And so that I think is something worth noting. If you're going to create a company, the first thing you should try to do is create a working prototype. Everything looks great on PowerPoint. you can make anything work on PowerPoint. But if you have an actual demonstration article, even if it's in primitive form, that's much more effective for convincing people.
So let me follow Elon Musk's advice, and let's go look at the model and see how these three different tornado charts were generated. Here's the model. There are two variables. Variables 1 and 2. And the first variable has a range from 7 to 15 with a most likely of 10. And the second variable, minimum of 5, maximum of 20, and the most likely of 10. And therefore, in the mathematical tornado chart, this center line, which I said was 100, is simply multiplying these two variables together. And if I take a mathematical sensitivity of plus and minus 20%, that means the low is 80 and high is 120 for both variables, I get the results shown here. I'm going to move one at a time. So 8 times 10 is 80. 12 times 10 is 120, same for both variables. That's what gives me this particular chart. Remember, this chart's really only good for testing the model to see if it goes in the right direction. The second chart is the percentile. And here I want to take the percentile of these two variables. I've used SIPMath to calculate the distribution. Here is the distribution of these two variables. Variable 1 is shown here in orange, if you will, and variable 2 in the blue. And you can check that yourself by looking at these ranges. If I take the P10 ranges for variable 1 are 8.4 and 13.1. Clearly this is a little bit higher than 8, and this is certainly higher than 12. And the range for variable 2 is 7.7 and 16.2. This is lower than the 8, and this is much higher than the 12. So as a consequence, when we put those into the model, we find these results. It goes to 84.4, 130, 77, and 161. This is the tornado chart typically used in most uncertainty analysis. A tornado chart is almost always utilized. The worst type is the mathematical ones. And this is the most common one, the percentile one, where you've taken the P10 and the P90. That's what you're supposed to do. And you change one variable at a time. And that came about because that was something easy to do with the decision trees. However, decision science and decision quality has advanced, and we've moved on mostly to Monte Carlo. And what that means is that we don't have to do one variable at a time. We can change one variable and keep all the others uncertain. So when we do that, we're going to hold the variable 1 at the P10 value, which remember was 84.1, and let variable 2, the blue line here, remain uncertain. And when we do that, we get this result for variable 1. And similarly, when we put variable 1 at the high value but kept variable 2 totally uncertain, you get this value. Similar argument for variable 2. So this gives a very different answer. And so what this chart's showing down here, this chart is showing how the expected value, which is about 125, I think it's 123, how this expected value changes if we could control only one of the variables and let all the other variables in the model stay uncertain. Whereas this is showing me if I control a variable to the low or the high and kept all the other variables at the mid values, in this case 10 for variable 2 if I'm varying variable 1, it shows me how the deterministic value would change. So very different results. Thank you for watching. If you're interested in getting a copy of the model, please contact me at brian@theputz.com. I'd be happy to send it to you. If you'd like to learn more about SIPMath, I suggest you visit probabilitymanagement.org. They have a wonderful website with all kinds of tools there, shown down here, who they are. You can download models, and there's tools down here to include the SIPMath toolbar itself. You might also read The Flaw of Averages by Sam Savage. And please visit my YouTube channel. I have over 80 videos that cover a wide range of topics to include uses of the SIPMath tools, how to use the icons, cost and schedule risk analysis, portfolio analysis, value of information, lots of videos on that, and some mind testers. Hope you enjoy. Thank you.